Good afternoon, everyone. I want to thank the organizers for inviting me today because this is actually the first anniversary of Army Research Lab West. Yesterday we celebrated the first anniversary of the ribbon cutting, and we don't want to be a well-kept secret. We want everyone to know that we're here. We're here to present you with interesting problems for our future Army and solicit your interesting and clever answers, and we'll do that in multitude of ways. So today I'm just going to talk about our intelligent systems research and its long-term goals. Basically, we want to move from robots being tools that require an intense amount of soldier time to being teammates that, when appropriate, make their own decisions, know when to ask us to disambiguate a situation, and help us do things more effectively, but put fewer soldiers at risk. So right now we do use robots. We use them to go into terrain that we can't go into easily. We use them to go into situations that are dangerous, and we'd rather blow up a robot than accidentally lose a soldier. But right now it takes a huge amount of soldier time to run a robot. They joystick it, they're totally focused on what the robot's visuals show them, and they guide every single movement of the robot. So while that soldier is standing there joysticking the robot, there's another soldier standing there guarding the robot controller. So that's two soldiers to do one mission with one robot. Need to move away from that. But right now it's a great tool. It's a tool that protects a lot of soldiers, gets a lot of very dangerous missions done without putting our sons and daughters at unnecessary risk. So we're looking at the fundamental science. We're not building things. We're buying other people's robots, and we're playing with them to see what they can do for us, what we need to learn, what we don't know, so we can do this better 20, 30 years from now. So we have a lot of underlying assumptions. We have a different definition of swarms than a couple people here. 10 small robots will be a swarm for us. Can we do more? We would love to do more. But we're going to start with, can we make a small group of robots collaborate, share, understand the mission intent of the commander, squad leader, team leader, whomever's in charge of the mission, and understand when they lose a robot teammate, who takes over that mission. If the robot leader, the one that has most of the knowledge of the overarching mission, if that robot is destroyed, how does the team come back together to understand and continue to carry out the mission? So we need to think about this in terms of understanding long-term intent, short-term goals. If a robot gets trapped, how do you disambiguate its goals, its location, its current mission? And then how does it operate in different environments? You know, we have the Mars rover, challenging environment. Inner cities, very challenging environment. Tunnels, challenging environment. Under jungle canopies, another challenging environment. And yet robots, because of their ability to fly under the canopy, might actually be able to help us solve jungle warfare problems that we haven't been able to solve before. Can they set up a comms network for us? Can they map areas we were unable to map before so we know where we're going before we get there? So how do we create a teammate? Some of that is building trust. Trust in its behaviors, trust in its communications. So we build that with humans almost naturally. Some people have no problem building that kind of trust with an inanimate object. A lot of people have that kind of trust with their car. They name it, they love it, they care about it more than they care about a lot of things. So there are people who already build that kind of a almost emotional relationship, trusting relationship with an object. How do we build that trust from soldiers to their robot teams and amongst the robot teams? Because the robots may not all be the same. They may be a heterogeneous mix, much as a squad has a few riflemen, a radioman, a machine gunner, a team leader. They all have different missions, they carry different capabilities. We'll probably have a similar type of mix with robots so that the robot is very capable and able to do the mission very exactly with minimal load, right amount of power, and able to last the right duration for the mission. So heterogeneous teams of people and machines. How do we build trust in information? Trust in the mission. Trust in getting the mission done. Trust in saying, I can't get my mission done. I'm stuck, I'm broken, whatever. So that you have this true trust. And then the information that comes back needs to be in a form that soldiers understand. So we'd like to be able to talk to the robot, tell it where to go, tell it what the goal is, have the team of robots understand and go off and do the mission. But they're not going to talk back to us. Robot language is difficult to hear at best. So maybe it sends us a picture in augmented reality glasses. It tells us where to look, tells it what it's achieved, shows us where it's going. So how do we do that? Also, the deep learning aspect. We have a lot of knowledge on how to do deep learning and machine learning for large data sets. Military data sets are sparse. Can we take a sparse data set, start to learn from it, have the expert evaluate what the robot thinks it's learned, tell it what it should have learned, and have it be iterative, but build that base and then have it shared across other robots. So we're looking at those types of things. Can they understand a glance? Say, robot, I'd like you to go give the microphone to Ali. And he knows which Ali I'm talking about because I'm actually looking at it. And they understand where I'm looking, where I'm pointing, and I don't need to put a pointer, a designator on them. So they understand language, they understand gesture. So we set up the Intelligent Systems Center to look at all of these problems from different ways. So we have an entire program on natural language processing, and to be able to give intelligent agents verbal guidance, whether they're embodied or disembodied. Working with the robots for control, autonomy, mapping, information development, and sending information back to us. And then what do we want to do with our future systems? As I said, we want them to be teammates. We want them to give good advice back, question our guidance if our guidance seems incorrect to them. We may have told them to go down an alley and they can see right away that it's a dangerous alley. And they send back to us, this isn't a good path to go, we need a different set of plans. We wouldn't want them to go down that alley. A normal squad would say, I see a tank at the end of this alley, we're going to do something else. So we want the robots to be able to react the same way and to have that trust and communication and not just get angry because they didn't do what we told them to. Oops. 1, 2, 5. Okay. So we want different levels of reasoning in our robots. We want them to work with us, but we need them in combat zones to work through physical agents. But in our software systems, our communication systems, they may be completely disembodied. They may be looking for a cyber attack by watching network pacing, watching unusual piles of communications in a certain area. We also want to use them to look at social media. Perhaps we are not aware of the culture that we're operating in. And the social media's erupted because some soldiers are behaving in a way that's not concurrent with the culture that we're trying to live peacefully with. We really don't want to go in and destroy things. We would like to help bring peaceful resolution to things, to help people have their own autonomy, their own ability to run the country. And yet a lot of things we do because of cultural dissonance, sometimes just from immaturity and experience of our soldiers, we make big mistakes. We can be watching this and be aware that those problems are happening before they become a major incident. Now, why are we out here at Los Angeles? Dr. Tom Russell, who's the new Deputy Assistant Secretary for Science and Technology, was ARL's director a little over 4 years ago. And he wanted to go back to Van Ivor Bush's concept of having industry, academia, defense labs, and other federally funded labs work together to create new knowledge that creates new capabilities and creates new markets that keep this country vital and strong and moving forward. And so instead of building walls between the research labs, he wants to open up the research labs, have people come work with us on our problems. We share our resources with folks. And so we've set up an ecosystem to allow academia, industry, and the labs to come together and work on problems that our training and doctrine, part of the Army, establishes, and that is guided by OSD guidance and funding. And so it's an ecosystem where our resources are available to you if you're working on our problems. So we have an interesting robotics lab back at Adelphi that you could come and use as long as you're working on a problem and you want to share the learning that you get from working on that particular problem with us. And we will share our IP and let you turn it into a product. The only thing we'll take is government purpose rights, which means you can't sell it to us at a more expensive price than you would sell it to commercial space. So for example, some of the virtual reality goggles were, the IP for that was created in our university-affiliated research center. They spun off a small business that got venture capital funding to take a $50,000 immersion goggle and turn it into a goggle that goes for anywhere from $300 to $3,000, depending on how realistic you want it to be. That was great for the government, because now we can buy that for soldiers at $300 a goggle instead of $50,000 a goggle. And we didn't have to put millions of dollars in to commercialize it and make it inexpensive to build. So that's the type of mutual benefit we're looking for by having this ecosystem back. So we're in ARL West. As I said, we're co-located with a university-affiliated research center called the Institute for Creative Technology, which is part of USC. They work on training effectiveness, immersive training, virtual reality training, and really looking at the compelling storyline of creating that virtual environment and immersing you. Can you enhance soldier training? Can you create skills retention without actually having to go and get into a physical system like a tank or a helicopter? Our focus, the piece that we're working on there, is human information interaction, how we're going to talk to robots, how our robots going to help us get information we need for decision making, and then how do we take that massive amount of data, turn it into information, and then parse that information into what you actually need. Because too much information is noise, and it causes analysis paralysis, and you can't make any decision. So how do we understand the temporal nature of the question you're asking, the data you actually need to make a good decision, how you like to see that information. Do you want a video? Do you want a graph? Do you want a 3D image of a network? How is it best for you to understand that information? And then the system will understand you, understand the information, understand the timeline of your decision, and provide you timely information in the manner you need it. So that's the work we're working on. Our biggest partners are USC and Santa Barbara at the moment on cognitive studies and information assimilation. But we're also working with UC Irvine, UC Riverside, building a larger ecosystem. And we had interns here last summer from 11 different universities. We had 16 summer interns, and then we had 3 Thurgood Marshall Scholars. This summer we will have over 26 interns working on these different types of problems. Anything that ARL does is fair game. So we have our Open Campus website, which has every single research area we're working in and descriptions of the problems we would like to collaborate on. And if you go to that site, you will have a point of contact who will tell you who is our lead for the area that matches the area you're interested in working in. So that's for our computational science campaign, our information science campaign, our material science campaign, our maneuver science campaign where physical robots tend to reside. We also have material science, so the fellow who's working protective materials that could also be antennas, that would be a great place for him to talk because we have our sensing materials, we also have our structural and protection materials. So we are looking for partners. We have positions. Now that the hiring freeze is lifted, we actually have about 11 positions I need to fill in Playa Vista. So there's definitely opportunities that will be rolling out this summer. And one of the reasons we came out here is we could attract researchers from the West Coast to work on interesting problems on the East Coast. But as soon as that interesting problem was solved, they found a job back here on the West Coast. And we don't mind training people and having people who understand Army problems go and work for somebody else. But boy, we'd like to keep a few of them for a few years longer. So being here on the West Coast gives us an opportunity for you to try us out and for us to use your great mental power on our problems and together really build a good team that's looking at national defense and helping us move forward. Thank you.